Hi, my name is VENKANNA KOTA. Welcome to my YouTube channel Electronics for Gate by KOTA VENKANNA. My mobile number 630-5826-909. In the last class, I have discussed types of materials. Now I want to discuss semiconductors. Semiconductors means which allows, these are one of the types of materials which allows partially flow of electrons, and the conductivity here, the conductivity directly proportional to concentration of free electrons. Conductivity is indicated with sigma, and concentration of free electrons indicated with small n. For the conductors, the concentration of free electrons approximately equal to 10 power 28 electrons per cubic meter, and for an insulators, concentration of free electrons that is equal to 10 power 7 electrons per cubic meter. And for semiconductors, concentration of free electrons lies in between insulator and conductor, that is 10 power 7 to 10 power 28 electrons per cubic meter. So here semiconductor materials which consist of valence electrons approximately equal to 4, that is half of the maximum. So here maximum valence electrons 8, half of the 8 approximately equal to 4. So here, for example, carbon, if you see the carbon atomic number of carbon is 6, element carbon C, atomic number 6, the configuration 1s2, 2s2, 2p2, 2 plus 2 4, 4 plus 2 6, but s orbital filled with 2, s orbital filled with 2, but p orbital for need filled with 6, but here only 2 is there. So 4 is valence electrons. Similarly, for silicon, the atomic number is 14. The configuration is 1s2, 2s2, 2p6, 3s2, 3p2. Here p is filled with only 2, 4 is remaining empty. Similarly, germanium atomic number 32. The configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. So here p orbital filled with only 2, remaining 4 are the valence electrons. So this is the configuration of semiconductor materials: carbon, silicon, germanium. So here valence electrons which consist of 4 valence electrons. So here the structure of semiconductor, the crystal structure of semiconductor. So semiconductor which consists of tetrahedron. So here the atom is a semiconductor atom is a tetravalent atom. So here this is the crystal. For example, 4 valence electrons, germanium. If you take germanium atom, 4 valence electrons. This is 4 valence electrons. This is 4 valence electrons. So every atom, for example, this is germanium, these are the germanium atoms. So every atom which consists of 4 sides, 4 valence electrons, 4 sides, 4 valence electrons. So here 4 sides, 4 valence electrons, so every atom which consists. So here this atom valence electron, this atom, neighboring atoms are combined with the covalent bond. This bond is known as covalent bond. In between two atoms, these two electrons are bonded with the covalent bond. This bond is covalent bond. Atom is tetravalent atom, and in between atoms bond is, this is covalent bond. Covalent bond. So due to the covalent bond, availability of free electrons very less. So this is free electron, this is free electron, this is free electron. So availability of free electrons are very less. So that's why at 0 degree temperature the conductivity is 0. So why? Because conductivity is directly proportional to concentration of free electrons. But here here availability of free electrons are very less. So that's why conductivity is 0. So by increasing the temperature, the semiconductor conductivity increases. So how the conductivity increases means, so when we are applying the temperature due to the thermal agitation, the covalent, any of the covalent bonds will be, for example, this bond, covalent bond will be broken, then availability of free electrons are increases. So due to the temperature, if this covalent bond is broken, so these two are available as a free electrons. So that's why when the temperature is increases, some of the covalent bonds will be broken due to the thermal energy. Then availability of free electrons are increases, then conductivity increases. So that's why at room temperature, semiconductor acts as conductor. And the transport. Semiconductor basically which consists of two carriers, electrons and holes. So in a pure semiconductor, the number of electrons equal to number of holes. So here we have to see the transport of carriers. So for example, this is electron carrier. So here this is hole, this is electron. So here when the electron, for example, this is electron. So this electron is jumped into the hole. When what will happen? The hole is transferred to this place. One step forward electron, and then hole is backward one step. So here, if the electrons are traveling in this direction, then holes are travel in this direction. The distance of travel of electrons and holes are equal, but the direction is opposite to each other. Here, hole. What is hole? Hole is absent of electron. Empty of electron is nothing but hole. Hole is considered as positive charge. Why? Because there is no negative charge. The absence of negative charge is called as positive charge. Negative charge is called as positive charge. And at room temperature, Eg value is equal to 0.72 electron volts for germanium, and Eg is equal to 1.1 electron volts for silicon at room temperature. Semiconductor which consists of electron and hole pairs. If we are increasing the temperature, new electron hole pairs are generated. At the same time, an electron hole pairs are disappear due to the recombination. So here, what is recombination? This is electron, this is hole. When the electron jumped into the hole, then immediately the hole and electron both are disappeared. This process is known as recombination. Due to the recombination. So when the recombination occurs, immediately one electron hole pair is disappeared and immediately another new electron hole pair is generated. So this is about semiconductors, and in the next class we will discuss the conductivity of a semiconductor. In gate point of view, in this topic the bits covered are, first one is conductivity directly proportional to concentration of free electrons, and for the conductors the concentration of free electrons approximately equal to 10 power 28 electrons per cubic meter, and for the insulator the concentration of free electrons 10 power 7 electrons per cubic meter. And semiconductors, here the semiconductors concentration of free electrons lies in between conductors and insulators. And valence electrons of semiconductors approximately equal to 4 or half of the maximum valence electrons. In a pure semiconductor, the number of electrons equal to number of holes. Next, at room temperature, Eg value is equal to 0.72 electron volts per germanium and 1.1 electron volts per silicon. Here, the transport of carriers, electrons and holes traveling distance is same, but the direction is opposite to each other. Here hole is a absent of electron, which is considered as positive charge, and the crystal structure of semiconductor is tetravalent. The crystal structure of semiconductor is tetravalent, and in between any of the atom the bond is covalent bond. In covalent bond, how many electrons are combined, connected, and 2 electrons, the neighboring atom, 2 electrons combined are connected in covalent bond. So when the covalent bond will broken, when we are increasing the temperature due to the thermal excitation, the covalent bonds will be broken, then conductivity increases. So here at 0 degree Kelvin, semiconductor acts as insulator. At room temperature, semiconductor acts as conductor. So due to the recombination, the electron and hole pair disappear and immediately another electron hole pair is generated. And similarly, when the temperature is increases, new electron hole pair is generated and another electron hole pair is disappeared. For the carbon, the atomic number 6, for the silicon atomic number 14, for the germanium atomic number 32. These are the bits covered in gate. So this is also very useful for IES, Indian Engineering Services, and gate. Thank you. For daily classes, subscribe my channel. My channel name is Electronics for Gate by KOTA VENKANNA. My name is VENKANNA KOTA. My mobile number 630-5826-909. Thank you.